So if you're looking for a project to do with your CodeX, look no further. CodeSurfer has surfed into town. This project uses a CodeX to control a micro servo to which is attached a surfboard. And there's a little bit of 3D printing to do here to make the attachment from the surfboard to the servo. And you can also 3D print the entire surfboard if you want to. If you don't want to, we've got details on the construction materials in the show notes. This also shows you, when we'll talk about the code later, how to program the CodeX to control the servo, but also to read the accelerometer. And we'll make it so that as you tilt the wave, the surfboard can keep up with that and you're actually surfing in real time. So lots of cool elements to this project. Hope you enjoy it.
All right, let's take a look at the code for CodeSurfer. So we import our libraries, we set up a CodeX servo port. So we're using port 1 on the CodeX, that's the one right here across the top of the CodeX. And we're using the expansion port object from the CodeX library. So when we do from CodeX import star, we get that EXP expansion port. If you want to look at the docs for that, you can go to our documentation link. So this is the docs.verylabs.com. Go to the CodeX Python modules, and then the expansion port here actually defines all the GPIOs that are brought out on the front expansion connector, as well as the ports across the top of the codex. So here's that make PWM function. It's going to set this to a pulse width modulation output so we can control a servo with it. And then there's another function that's called set servo that lets us set a position. So we'll be using that function just below. So first we're going to draw some background art, so you can use the JPEG file of your choice to adorn the display. And then the move servo function just takes an angle and it converts it to a percentage that is required by set servo. And this was just experimentally derived. So we looked at what would it take, what value would you have to set the servo to get about a 90-degree sweep of the surfboard. So you can experiment with that and set the right values yourself. We're reading the accelerometer and then converting that to 2 degrees as well. So we read the X, Y, and Z components of acceleration. And remember, the accelerometer is a 16-bit device, and full scale is going to read a signed value that's going to be 32,768 plus or minus. We're only using half of the full scale range because full scale it's 2G, and since we're on planet Earth, we're dealing only with 1G here. So we're on planet Surf, 1G still. So that's why the 16384 there. So we're using a little bit of trigonometry there to figure out our angle based on the accelerometer values. Okay, so now's our main loop here. We read the accelerometer just to get an angle. That's basically where the waves are sitting, right? That's the angle of the codex. And then if button A is pressed, we just add a little bit to the servo angle, increase that value up from 2 degrees to more or less based on how sensitive you want button A to be. Same with button B. And then we're just sleeping a little bit to debounce those button presses and make it so that the servos have time to change before we loop back around. So we set the servo angle, and here is some code that sometimes we'll use this like at a STEM fair or a maker fair and have people write their own code with the surfboard. So you can make it rollick up and down all by itself, or you can, in this case, we're using that accelerometer angle to set the servo. So this is where you get some crazy surfing action when you move the waves back and forth. And then finally, after you're finished adjusting the servo angle, we're gonna actually move the servo to that new angle, and then we update the display. So you can see we're using some string formatting so that we can display both the servo angle that it's currently set to and the codex angle that the accelerometer is currently reading. And that's it. That's CodeSurfer. Happy coding.